Hi everyone, I'm going to help you work on 7.1 video today. Before that, let's review what we have learned about graph of sine and cosine. So we learned that graph of sine and cosine are called sinusoidal functions because they are functions that are periodically repeating themselves. Like this is sine, it's repeating itself forever from left and the right, and the same is for cosine. So when we're talking about graph of sine and cosine, usually we're talking about one section of the function which is not repeating. Like between these 2 points, the function is not repeating, and right after this one, it's going to repeat itself, or before this point. The same is for cosine. We learned that one cycle is the section of the sine or cosine which is not repeating. Now, what is the period of this function? The period of the function is the number of the degrees or the radians that this function needs to complete one cycle. For example, this one from 0 to 360 is the number of degrees that the function needs to repeat itself. So one cycle is 360 degrees. That is called period of the function. And the same here, between these 2 points is one cycle. How many degrees does it need to complete one cycle? 360 degrees. Usually when you're given the graph of a function like sine or cosine, in order to find the period, you need to find the distance between two repeating points. For example, for this point and this one are repeating each other. Not this one, because the difference between these 2 points are this. Right after this point, the function is going up, but right after this one, it's going to go down. So they are not repeating each other, but these two are repeating each other. Right after them, the function is going up. So if I find the distance between these 2 points, I have found the period of function. Another repeating point could be the two high points that we have. If you find the distance between high points, that's also period. Or the distance between the low points. The same is here. High points, two midpoints, or two low points. And they're all equal to each other. This is 360 degrees. This is also 360. From 90 to 450 is 360 degrees. So to find the period, you just need to find the distance between two repeating points. Next, let's talk about the critical points. On this function, critical points are this one 0 at 90, this is another critical point, this one 270 and 360. Why do I call them critical points? Because on these points, critical changes are happening to the function. For example, the function was increasing, right after that it's going to decrease. Decreasing, right after that increasing. Before this point it was a downward curve, right after that is an upward curve. The same is here. These are the critical points of the function. Now, how do I find the critical points? Notice that in one cycle I have 1, 2, 3, 4, 5 critical points. The same here, 1, 2, 3, 4, 5 critical points. And the distance between them are equal to each other. So in order to find the critical points, I need to divide the period of the function, which is one cycle, divide that by 4, because we have 1, 2, 3, 4 sections between them. So what I find after this point is the distance between the critical points. This is going to give me that the distance between these are 90. Now, how do I find the critical points? To list the critical points, I start from 0, then add the value of the distance to that, which was 90 in this case. So 90 plus 90, 180, plus 90, 270, plus 90, 360. And the same is here for cosine. So this is how we find critical points. There's also one more thing that we need to talk, and that's amplitude of the function. First of all, we know that sinusoidal axis of these periodical functions is the horizontal middle of the function, or this one, horizontal middle of the function. Now, amplitude is the vertical distance between the highest point and the sinusoidal axis, or this distance between the lowest point and the sinusoidal axis. The same is here, here, and here. So these are all the same, and they are equal to amplitude of the function. We also learned that if we make some transformations on our function, like this one, for example, or let's say y equal to sine of b theta, we are going to multiply the x value of the function, or theta, by a number. That means we're going to horizontal stretch or shrink our function. That is based on the value of b. If b is greater than 1, we are, I'm sorry, let me fix it. If b is greater than 1, shrink. If b is less than 1, we are stretching. If you remember, this is similar to y equal to f of, for example, 2x. We know that everything inside the function is weird, so this 2 is greater than 1, the function is going to be horizontally shrinked. Okay, so what is happening here? Let's say, for example, this is graph of sine of theta. It's the parent function of sine theta. If I change my function as y equal to sine of 2 theta, then my function is going to be horizontally shrinked. That means it's going to be something like this, for example. You see, the period was this before, but now it's smaller. I'm going to have a smaller period because it's horizontally shrinked. So the period of the function can be found by dividing the period of the parent function, which was 360. We know that the period of the parent sine or cosine is both 360. Divide that by b. That is going to give us the period of the new function. Or if you are working with degrees, with radian, you just need to divide 2 pi by b. And you will find the period of the function. Now, what if I want to find the critical points for this transformation? We know that to find the critical points, we need to divide the period by 4. So we found the period here. All I need to do is to divide that by 4. So 360 over b, divide that by 4. When you're dividing fractions, you're going to keep the first and multiply by the flip of the second one. So it will be 360 divided by 4b. So to find the critical points, you're going to divide 360 by 4b, or divide 2 pi by 4b. This is for y equal to cosine of b theta, or y equal to sine of b theta. So in this way, I can find the distance between the critical points, and then we can list the critical points themselves. Now, the next thing was this one. If I have y equal to a sine of theta, or y equal to a cosine of theta, in this case, we are vertically stretching or shrinking our function. If the a value is greater than 1, we're stretching. If a is less than 1, we're shrinking the function. Basically, let's say, for example, this is my function of sine, and I multiply the function by 4, for example. Sine of theta, 4 times sine of theta. Now, the new function is going to be vertically stretched like this. That means the amplitude of the function is changing. The period is the same, but the amplitude is changing. And the amplitude is equal to this A value. Okay? So once again, if I'm multiplying the theta by a value, we are horizontally shrinking or stretching. And that means the period of the function will change. But if you are multiplying the function by a number, like a before the function, multiplied by the function, then the amplitude is changing, not the period, only the amplitude. Okay, so let's work on some of the examples that we have on homework 7.1 homework. I'm going to start with this one. You know that you are supposed to work on the odd questions, and I'm going to do some of the even ones, so you will learn how to work on all these problems. We are supposed to sketch 2 complete cycles of each graph and label the critical points. So let's look at this function that we have. We have y equal to 12 cosine of 3 over 4 theta. First of all, I know that my parent function is y equal to cosine of theta. Just by looking at this graph, at this function, I will know that the parent function is cosine of theta. Now, what changes is happening to my function? First of all, I'm multiplying the function by this number. This is outside of the function, so this is the a value. The a value is 12, the same as what we were talking here. That's the a value. So if the a value is 12, that means the amplitude of the function is 12. The amplitude, as we learned, is the distance between highest point and horizontal and sinusoidal axis and the lowest point. That means the amplitude is going to give me the highest point, let's say for example 12, and the lowest point, which is negative 12 here. So we have the highest and lowest point of the graph at this point. In order to graph the function, I need the critical points. I know that cosine, parent cosine, looks like this. It's something like this. The critical points are here, here, this one, and this one. So I need to find these points on my new graph. Also, as you see here, we are multiplying the theta by a value, by 3 over 4. This is the b value, which is multiplied by theta. So 3 over 4 is the b value. This b value is horizontally stretching our function. That means the period of the function is changing. Now let's see what change we are going to see on our function. So I need to find the period of the function. We learned that if we are multiplying the theta by a b value, to find a period, we need to divide 360 by this b value. So divide 360 by 3 over 4. I'm dividing 360 because I'm told here that the function is working with decrease. If it was working with radian, I had to divide 2 pi by this value. Okay, so 360 divided by 3 over 4 is 360 multiplied by 4 over 3. And then it's going to be equal to 480 degrees. So my new period is 480 degrees. So I know that one cycle of my function, which is one period of the function, is 480 degrees. Since I'm supposed to graph 2 cycles, I need to graph another cycle. So another 480, let's say for example somewhere like here, will be 960 here. So these points that I draw here are the end of each cycle. One cycle is going to happen here, and another cycle is going to happen here. The next thing that I need to find is the critical points. If I find the critical points, then I will be able to graph my function. How do I find critical points? divide the period by 4. So 480 is my new period. I divide that by 4 and it will be equal to 120. 120 is the distance between critical points. So how do I find the critical points themselves? I'm going to start with 0. So the critical points will be 0. And then add 120 to that. So 120 is my next critical point. Next one, add 120, it's 240. Plus 120, 360. Plus 120, 480. So now one cycle is, the critical points of one cycle is found. I'm going to mark them here. 120, 240, and 360. 120, 240, and 360, and the first one was 0. Now I can find the others as well. So if I add 120 to 480, I will have 600 here, then 720, and then we'll have 840. So these are all the critical points that I have between these two cycles. One cycle, two cycle. Now I'm ready to graph my function. How do I graph it? Look at the parent function of cosine. It's a high point. So the first critical point is a high point, then middle point, low point, midpoint, high point. So high, mid, low, mid, high. So I'm going to do the same thing. The first critical point is a high point. Next is a midpoint. Next is a low point. Then midpoint, then high point. The high and low points are basically the amplitude. The amplitude was 12, so that's why I went for 12 points here. Okay, so now I'm ready to graph my function, the first cycle of my function. And it's going to be something like this. This is the first cycle. Now let's graph the second cycle. Again, start from here. The first one is a high point, then midpoint, low point, midpoint, and a high point. Now this is the second cycle of my graph. Now let's work on number 8 here. Again, my parent function is cosine y equal to cosine of 1/6 times that. Oh, I'm sorry. My parent function is y equal to cosine of x. So what transformations do I see here? One of them is this. That's the a value. It's 10. That is going to give me the amplitude of my function. So that means the highest point is 10 and the lowest point is -10. Amplitude of the function. Next, I am multiplying my function by a number. I mean the theta value or the x value by a number. This is the b value. B is equal to 1/6. Using the b value, I can find the period of the function. Because I'm working with radian, to find the period, we need to divide 2 pi by the b value. So divide 2 pi by 1/6. So it will be 2 pi times 6/1, which is 12 pi. So that means one cycle of my function is going to take 12 pi. So let's say, for example, this one is 12 pi. Because I need to graph 2 cycles, I'm going to do next one as well. The next cycle will be 24 pi because I'm going to add one cycle to this, 12 pi to this one. It will be 24 pi. Then I need to find the critical points. To find the critical points, take the period, which is 12 pi, and divide that by 4. So it will be 3 pi. This is the distance between the critical points. I'm going to call that just for short, I'm going to call that the steps of critical points. The steps that we need to go forward to find each critical point. So let's start. I'm going to start from 0. That's my first critical point. Next one will be 0 plus 3 pi. So 3 pi. Next one, add 3 pi to that, 6 pi. Add another 3 pi, and it will be 9 pi. And another one will be 12 pi. So these are the critical points of first cycle. The second cycle, let's draw it with another color. 12 pi plus 3 pi will be 15 pi. Another one, plus 3, 18 pi. Another one will be 21 pi. 21 pi. So I found my critical points. Now I know that graph of cosine looks like this. High, middle, low, middle, high. So the first critical point is the high point, next is middle, then low point, middle point, and high point. So that's the first one, and the second one again, high, middle, low, middle, high. So we graphed 2 cycles here. Now let's quickly work on number 6 as well. So we have y equal to 5 sine of 4 pi x. The parent function is y equal to sine of x. A value is this, the number which is multiplied outside of the function. A is 5, that means the amplitude is 5. So my function is going to go 5 up and 5 down for the highest and lowest point. The b value is 4 pi. You see, 4 pi is multiplied by x. B value is 4 pi. So from here, I can find the period. Period of function is 2 pi. Because we are working with radian, I'm going to divide 2 pi with the b value. B value is 4 pi. So if I divide them, these two will go away, and it will be equal to 1 over 2. Okay. Now, how do I find the steps of critical point? Take the period of the function and divide that by 4. So this is 1 over 2 times 1 over 4. And it will be equal to 1 over 8. Okay. So now I need to find the critical points. One period of the function is 1/2. So let's say here, this is 1/2. Another period of the function is going to be 1/2 added to that, which is 1. Okay. Now how do I find the critical points? Start with 0. Add 1/8 to that. So that's the first point. Add 1/8, it will be 1/8. Next, add 1/8 to this one. So it's 1/8 plus 1/8, which is 2/8. 2 over 8. Add another 1/8 to that. It will be 3 over 8. Add another one and you will reach to 1 over 2, because 3 over 8 plus 1 over 8 is 4 over 8, and you simplify that as 1 over 2. So this is basically the same as 4 over 8. Now to find the next critical points, you're going to add 1/8 to this. So just to make it easier for myself, instead of 1 over 2, I use 4 over 8 and add 1/8 to that. So it's 5 over 8. The next point is 5 over 8. Another 1/8 to that is 6 over 8. Another one, 7 to the 8. And another one will be 8 over 8, which is just 1. Okay, so I found my critical points. Now I'm going to graph my function. Sine looks like this. This is graph of sine. You need to remember the parent function of sine and cosine. So sine is a midpoint, then a high point, mid, low, mid. So I'm going to do the same thing here. First one is midpoint, then high points, mid, low, mid. So this is one cycle. And the next one, mid, high, mid, low, and middle. So this is the graph of my function. So I need to work on the other problems, the odd problems, the same way that we have worked here. Good luck. Have a great day.